Good afternoon. Welcome to the second Bureau of Business Research webinar of the 2025 Spring Series. Today's presentation is sponsored by the Bureau of Business Research within the Department of Economics at the College of Business at the University of Nebraska-Lincoln. My name is Mitch Harry and I serve as a project director at the Bureau. Today we're going to hear from 4 Bureau of Business Research scholars who have been working with us this year. These students have worked hard all year receiving training in research methods and developing research topics for presentation. The 4 presentations are diverse and provide a solid example of the types of research that students conduct at the Bureau. The research presented today has recently been presented at the UNL Undergraduate Research Days, and we are excited to share the research with you. Before we begin, I'd like to point out several features of the webinar. As you can see, a chat window is available where you can chat with other participants. And a Q&A window is available where you can type in questions for myself or the students at any time. We will answer these questions after the presentation has been completed. A little bit about the BBR Scholars program. The program was established in 2018. The program provides undergraduate students with an opportunity to participate in meaningful economic research. Scholars may work on Bureau-sponsored projects or potentially develop their own research agenda. Mentoring is provided by Bureau faculty and staff as well as senior peers. Currently, we have 6 BBR Scholars in the program. We also have 37 alumni who have gone on to work in industry, government, and graduate school. In addition to executing research projects, scholars participate in a seminar series. The seminar topics include how to use software for data analysis, specifically R and Excel. We focus on data visualization, data analysis, including regression techniques. And as I mentioned, research fair occurs every spring, where we also prepare students to present their research at that research fair and on today's webinar. With that, I would like to now turn the presentation over to Grace Hecke, who examined the impact of parenthood on earnings for men and women in the U.S.
Yeah, I'm Grace Hecke, and I did my research on the topic of how does parenthood impact earnings over time, and then to what extent does this impact differ by gender? So to answer this question, I use data from the PSID Panel Study of Income Dynamics, which is a longitudinal household survey. The model represents over 5,400 individuals from this study who were followed over varying periods of time between the years 1990 and 2020. I used a machine learning-based OLS regression model, which was used to predict annual earnings based upon the number of years it's been since an individual has had their first child, as well as annual labor hours, their industry, year, and the other variables represented there in that chart in the center. For some context, this study does not include individuals who are outside of the workforce, so we are only looking at people who are actively working, actively job seeking, or who are temporarily laid off. What we found is that the onset of parenthood has a moderate but negative long-term impact on women's earnings relative to men's earnings. So we show a baseline gap of around $7,700 and controlling for relevant variables. Each year after having a firstborn child, male earnings are going to increase by about $726 each year, while female earnings are going to increase by only $117 each year, thus compounding and widening that gap over time. As for the limitations of this model, we achieved a resulting R-squared score of about 0.38. So for longitudinal earnings data, that's going to be moderate explanatory power. But in order to improve this study in the future, incorporating additional variables would be valuable, or utilizing a panel method to control for those kind of personal household factors that we can't necessarily see in the data would also be valuable.
Okay, thank you very much, Grace. Next, we have Aaron Morrissey, who looked at the defense spending on technology industries in the United States.
Hello, my name is Aaron Morrissey. I'm a junior data science and economics major over at the Rake School, and of course, a researcher here at the Bureau of Business Research. But the point of my study here was to predict where defense tech contracts are awarded and all of the factors at play that kind of drive that spending. So personally, I'm just really interested in public money, kind of government money, and where that gets spent, as well as the technology sector specifically. So I thought this project would be a really good combination of those two things. But starting off with kind of the methodology, I took all of the contract data from usaspending.gov and from the Department of Defense, and then I merged that data with some county level employment, wage, income, and education data from the Bureau of Labor Statistics and the American Community Survey. And then I merged these two data sets together based on specific tech-related industry codes. So after I filtered all of that down, I did a linear, lasso, and random forest model as sort of a robustness check on all of the data to find the most impactful variables. And then I also log skewed some of that contract spending to prevent some of the larger spending counties from affecting the data too much. So as you can see kind of on the map here, a lot of the technology spending would be concentrated in some of the larger military and tech hubs, looking at places like Southern California, Northern Virginia, as well as Massachusetts. But you also see some spending, interestingly, in some of the more rural counties, which would be explained by the presence of military bases or specific larger defense contractors. But ultimately, what you see from the regressors is that the biggest factor is actually the percent of people in the county with a bachelor's degree, as well as the average pay and employment within the tech sector. Those are the factors that drive technology spending in the defense sector the most. But you also, interestingly, see a slight negative correlation when it comes to the number of establishments, which I would attribute to possibly economies of scale. So some of the larger contractors potentially taking out some of the other competition and receiving more contract dollars. But ultimately, as far as policy implications, this data could be really useful to sort of regional planners, showing that they need to really invest in their human capital, making sure their workforce is well educated and well paid. But in the future, if I was to do a little bit more on this study, I would do things like doing more of a multi-year analysis through a decade and seeing how spending changes. And I could also add in some more variables, things like demographic and geographic variables into the data set. But thank you.
Okay, thank you very much, Aaron. Next up, we have Madeline Splichal, who examined producer services in micropolitan areas in the Midwest.
Hi, thank you, Dr. Harrian. So I worked on this project with Anna Mai, who unfortunately could not join us today, but we looked at the different factors that affect the concentration of producer services industry, specifically in our Midwestern states and Midwestern counties, and even more specifically within our micropolitan counties. So here we're looking at counties with a population of under 10,000. So a lot of the current research right now with producer services industries focuses a lot in our metropolitan areas. So our Los Angeleses, our Atlantas, but we wanted to kind of broaden what's currently out there by looking at our smaller counties as well. So what is the producer services industry? So essentially what they are is they're companies that do work for other companies. So think a lot of your like white collar jobs like accountants, computer designers, companies like that, who are typically paid a higher wage than normal industries. And it's also very rapidly growing, especially when we look at other industries. For example, they've grown almost 30% in the last 10 years alone, which is an extremely high growth rate. And it's a lot higher than the national average for industries outside of the producer services. So the main thing that we wanted to look at is what exactly affects this high growth rate, what actually affects this concentration that we're seeing. And like I mentioned previously, we looked specifically at Midwestern micropolitan counties in this study. So what we did is we gathered data from a lot of different government databases. So you can see here some of the different variables that we looked at were if there was a college nearby, the state income tax. We looked at Republican concentration and then producer services average weekly wage, among others. So we ran a regression on this and found a regression that gave us some good statistics. So we found the R-square to be pretty high, especially when you're looking at, industry studies. It's kind of difficult to include all the different variables. So an R-square of around 0.37, which is what we found is considered pretty moderately explanatory in this case. And we found a few different variables to be statistically significant. So we found that the manufacturing industry concentration was significant with a negative correlation. We found the average weekly wage in producer services to be significant. And the idea of this one is that if you have a higher weekly wage in one city compared to another, you're probably going to have more producer services workers drawn to that area than the one that offers a lower wage. We also found population to be significant, as well as the state income tax. And then we found the number of metropolitans in the state to be significant as well as the percent of the population within the county with a bachelor's degree or higher in 1990. And the surprising thing about this one is that it was actually a negative coefficient. So typically when you're looking at producer services, since these are your more white-collar jobs, your lawyers, these are the jobs that are typically extremely positively correlated with education, because a lot of these workers have, and if they're required or heavily encouraged to have a college education. So usually it's a very strong positive correlation, but here with the number of degrees in 1990, we found that to actually be negative, which was surprising for us. And one way that we kind of thought about explaining this is it could be representing sort of a brain drain idea. So if you have parents in these smaller micropolitan counties, think a lot of your small towns, these parents are probably going to have a lot more, a higher income typically, and they're going to be able to offer their children just some more opportunities. Because typically we've seen that if children have parents who attended college, they're more likely to attend college as well. So they may have some more opportunities to sort of leave the micropolitan counties and be drawn towards the larger metropolitan cities. And yeah, so we found that to be sort of an interesting kind of take on a brain drain idea. So yeah, those are the factors that we found to be significant. And since this is such an important industry, we thought that it was pretty important to look into what actually impacts the concentration that we see in our different smaller economies across the Midwest. So yeah, thank you.
Okay, thank you, Madeline. Finally, we have Ryan Tillotson, who studied the factors associated with employment in the tech industry in the United States.
Okay, hi, thank you. So for my largest project at the BBR, I assembled a dashboard basically looking at tech employment in the United States from 2019 to 2023. So I thought it'd be interesting to take all that data that I had and to then examine sort of like factors that increase tech employment within states, like what's actually associated with greater tech employment. Mainly with the motivation being that states are incentivized to have greater tech sector employment within their states due to the high wages and potential for wage growth within these occupations. So they're incentivized to sort of try to keep those high wages within their state if they can attract that employment. So I was curious to see what would affect this level of employment, and also if states could have sort of a large amount of influence on this to incentivize greater tech employment. So to do this, I took all this tech employment data that I had and then ran multiple linear regressions looking at the various factors that I thought that could affect tech employment and then relating it to the share of statewide employment that is within the tech sector. And as for what determines an occupation being in the tech sector, this is based off of Bureau of Labor Statistics data looking at occupations, and then also classifying them as tech sector or not based off of a computing Industry Technology Association report classifying different occupations as such. So as you can see on my poster here, we have one main multiple regression, which I use for a lot of my results. It had an adjusted R-squared of 0.6143, suggesting a fairly decent amount of explanatory power. And I'll just run through the variables here to sort of examine the results. So by far, the largest determining factor of how much tech employment is within a state is the educational attainment within the state. Specifically, for this variable, I use the percentage of the population which has a bachelor's degree or higher. This was very statistically significant. It has a very large effect on the amount of tech employment within the state, which is probably somewhat unsurprising. Then another interesting policy which was recommended to me to look at is states requiring high schools to allow computer science credits to count towards math or science. So basically, then high school students who are interested in computer science can use their computer science classes to count towards these other requirements to graduate. And by implementing this policy, we see a very statistically significant increase in tech employment, albeit a fairly marginal increase. But this is still a fairly easy to implement policy that does increase tech employment in the long run. Then moving down the list, we have RPP, which stands for regional price parity. And this is basically just a measure of cost of living. A higher regional price parity indicates that the cost of living within the state, or in this case, looking at specific metropolitan areas, is higher. So this was found to be statistically significant. However, it has a positive relationship, indicating that higher cost of living areas are correlated with higher tech employment. So I wouldn't necessarily expect this to, on its own, be a causal relationship. However, I do think that something more interesting is here when we consider the fact that I found in this model that RPP did not have any statistical significance until I included the variable you can see two below, the natural amenity scale. And the natural amenity scale is calculated by the U.S. Department of Agriculture. And it's basically just a measure of how sort of desirable an area is to live in based off its pre-existing natural amenities, right? So this is looking at things like mean temperature, humidity, sunlight hours, percentage of the area that's that's made up of water, right? Things like that, which are sort of like outside of direct human control. And then when that is included in the model, we then find that regional price parity is statistically significant, which I believe likely indicates that people in the tech sector, or probably high wage jobs in general, are willing to pay for that higher natural amenity scale with a higher cost of living, as these are more desirable areas to live in. Okay, and then moving down, we have FTE spending, which is full-time equivalent student spending. So this is spending by state governments on higher education on a per student basis. And here we don't find a very large amount of statistical significance. It is marginally significant, but nothing too strong here. But what's interesting is that it actually has a negative relationship, which we probably wouldn't expect to see, indicating that higher FTE spending is correlated with lower tech employment. However, I believe that this is likely due to collinearity within this multiple regression, as running separate linear regressions with just FTE spending and other variables indicates that it is associated with higher tech employment on its own. And also a reason for this being is because it's correlated with a higher educational attainment, looking at that bachelor's degree or higher percentage. So I believe that it does still impact tech employment positively. It's just somewhat drowned out in this multiple regression model specifically. And then lastly, I also looked at R&D expenditures by the state. This was not found to be statistically significant, so it's not really worth touching upon. And then finally, for just two other side things that I did that aren't in this model, I looked at top marginal corporate tax rates within states. These were found to be statistically significant. However, again, with a somewhat surprising positive relationship indicating that a higher tax rate is associated with greater tech employment. Similar to previous variables, I don't think this is likely a causal relationship. I think it's just a correlation that these higher wage areas tend to have higher taxes, potentially because of the potential to extract more revenue from that, but I don't think it's causal. And then I also, as a side, looked at net migration, interstate migration, specifically from IRS data. This was not statistically significant, did not have very much explanatory power. I was just sort of curious if states that were attracting a lot of migration from other states were sort of capturing greater tech employment, but at least within this model, that didn't seem to be the case. So for my final results, basically in sort of conclusion, as I previously stated, educational attainment is by far the largest determining factor for tech sector employment within a state. And a lot of the other policies that I looked at that I believe the states could have more control on didn't really bear out to have a large amount of influence over tech employment. However, I do think that would be worth going forward and looking at other variables that could affect this educational attainment. And you might find a greater ability for states to influence tech employment if they can increase their educational attainment within their states. And then one other interesting thing is I do believe that the data I found can be more prescriptive for some areas than others. For example, if we look at the Midwest data, because I ran this model on some specific state regions, looking at the Midwest, it's almost entirely driven by the natural amenity scale. It's by far the most statistically significant factor, indicating that's very largely outside of the government's hands and other associations, and that's largely due to just how attractive an area is to live in. Meanwhile, if we look at the Northeast, I found that FTE spending, that higher education spending, was the most significantly significant, which seems to suggest that governments or states within the Northeast could potentially see higher tech sector employment if they invest more in their higher education. So yeah, thank you. That would be my findings.
All right, thank you very much, Ryan. And I'd like to also thank all the scholars for all their work this year at the Bureau. As I mentioned, these 4 research projects are pretty representative of the types of work that students are pursuing when they work with the Bureau, though there are many other projects that they help us on as well. That concludes our presentations today. We do not have any open questions at this time. So I'll just put my contact information there. If you had any questions for me or any of the scholars offline, feel free to send me an email there. If you're already not following us on various social media outlets, please feel free to follow us on any of those you see on the screen. And also, if you're not already subscribed to our newsletter, please feel free to reach out to our team to get signed up. With that, I'd like to thank everyone for joining us today, and we appreciate your attendance. Thanks.